Okay, this video will go over rectangular coordinates and graphs and the coordinate plane. But before we do that, let's go over the concept of ordered pairs. Ordered pairs consist of two values, the independent value and the dependent value. And I abbreviated both of them just because they're really long and I know I don't have good handwriting. And we write ordered pairs in parentheses with the independent value first and the dependent value comes second. Let's look at a generalized example before we get into how it applies to the coordinate plane. Alright, so here's the table with the average expense per household for various categories in 2008. And suppose we want to write an ordered pair pertaining to housing. If we want to write an ordered pair, we do a parentheses and be housing, comma, and then the amount they spent per year, which is $17,109. Because the amount spent depends on the category. Since the amount spent is the dependent value, it goes second in the ordered pair. Likewise for food, if you want to write an ordered pair for that, since the category is independent and the amount spent is dependent on the category, the amount spent would come second. So the category would be food and the amount spent, which I believe is $6,443, would come second. Now we're going to move on to the rectangular coordinate system. The rectangular coordinate system consists of two axes, which divides the graph into four parts, which we call quadrants. And here's a picture. Alright. If you notice, it has two axes called the x-axis and y-axis, and the quadrants are labeled quadrant 1, quadrant 2, quadrant 3, and quadrant 4, which I'm sure you can see the order in which they're labeled. And in case you haven't noticed, a point on the coordinate plane is labeled with the x-coordinate first. Like in the picture, they have the x-coordinate labeled as number A and the y-coordinate labeled as B. And pertaining to what we talked about earlier about independent and dependent variables, the x value is the independent value, and the y value, the y-coordinate, is the dependent value. Alright, and if you had 2 points on a coordinate plane, we'd need to know how to find the distance between them, which we'll go over on the next slide. So the distance formula, this is how we get it. Suppose you have the x-axis and y-axis. You have 2 points, point A and point B. And you want to find the distance between them. Alright, what you would have to do is use the Pythagorean theorem, and we simplify the Pythagorean theorem into what we know as the distance formula. Say if this is the y direction, this side right here, we can call that delta y, which we get by subtracting the y-coordinate from point B, which we'll call y1, and the y-coordinate for point A, which we'll call y2. So delta y would be equal to the absolute value of y1 minus y2. The reason we put it in absolute value is because we want it to be positive. It really doesn't matter which one you subtract first. All we want is the number, because distance is always positive. Likewise, this part here, we call that the change in the x direction, delta x. We get that by subtracting the x coordinates, x1 and x2. Remember, we get that. We put it in absolute value, x1 minus x2. And if you do the Pythagorean theorem, delta y squared plus delta x squared, you get the distance squared. So let's rewrite this on a neater page. The distance squared is equal to delta x squared plus delta y squared. So now if we want to solve for the distance, we can take the square root of both sides. So the distance is equal to, since we want it to be positive, we take the positive square root of delta x squared plus delta y squared. And delta x, we said, is equal to x1 minus x2 squared. Since we're squaring it, that'll automatically make it positive, so we don't need to put it in the absolute value. Likewise for delta y. So all we did from here to here is we just substituted delta x for x1 minus x2 and delta y for y1 minus y2. And this formula right here is the distance formula that we use to find the distance between 2 points on the coordinate plane. So here's an example. Find the distance between points P and Q. Now if we want to, now remember we have the distance formula. Remember it's square root of, it doesn't matter which x coordinate you put first and which y coordinate you put first, as long as you do the same one. Even then it really doesn't matter because you're squaring it. Just for the sake of simplicity, just put the same x and y's first and the same point second. Like for this one, we can just start with the q coordinate first. So it'd be 3 minus negative 8 squared. And then for the y coordinate, start with the q again. So it'd be negative 2 minus 4 squared. Remember, for the x1 minus x2, since you're subtracting a negative, those would both turn to addition. So it'd be 3 plus 8, which is 11 squared. And then negative 2 minus 4, which would be negative 6 squared. Now, 11 squared would be 121. Negative 6, since the negative's in the parentheses, when you square it, it'd become positive, so it'd be positive 36. So square root of 121 plus 36. Add those up, you get the square root of 57, which is approximately 12.53. So the distance is approximately 12.53 units. Now another way we can use it is if we're given 3 points, we could use it to determine if the lengths are the sides of a right triangle, such as in the following example. So, like in this example, it asks, are the points negative 2, 5, 12, 3, and 10, negative 11 the vertices of a right triangle? Meaning if you plotted them, would they make a right triangle? Remember, the first step to doing these is to plot them on a graph. Because it might help give you a better visual image. So here are the points plotted. Looks like it might be a right triangle, but the way we do that the way we confirm for sure is we find the lengths of each side. So we find the distance between M and N, the distance between N and Q, and the distance between point M and point Q. And then what we do is after we find the distances, we see if the distance, MQ looks like the longest side, so we take the distance between M and Q and square it, see if it fits the Pythagorean theorem. So if we add them, if we add the lengths of the shorter sides, if we square the lengths of the shorter sides and then add them, would it equal the length of the longest side squared? Meaning, would it fit the Pythagorean theorem? So let's go ahead and calculate it. The distance between M and N. Remember, point M was -2, 5. And point N was the point 12, 3. So if you plug that into the distance formula, it'd be the square root, subtract the x coordinates, 12 minus -2 squared, plus subtract the y coordinates, 3 minus 5 squared. So 12 minus -2, that would turn to addition, so it'd be square root of 12 plus 2, which is 14 squared. Now 3 minus 5 would be -2 squared. (14 squared is 196. -2 squared is 4, so that'd be 200. And you could simplify that, but for the sake of this problem, we're going to leave it as is. So we're going to leave it as square root of 200 for now. So make note that the distance from M to N is equal to the square root of 200. Now we got to find the distance between M and Q, because M we said was -2, 5. And point Q was 10, -11. So the distance between these would be equal to the square root of 10 minus -2 squared plus -11 minus 5 squared. That's equal to square root 10 minus -2. That turns to 10 plus 2, which would be 12 squared, plus -11 minus 5 would be -16 squared. 12 squared would be 144. -16 squared, since the negative's in the parentheses, it would turn to positive. So it'd be 256. And that'd be equal to the square root of 400, which would be 20. So the distance from M to Q is 20. Now we need the distance from N to Q. We remember N is the point 12, 3. And Q is the point 10, -11. So the distance would be, do the square root, subtract the x coordinates, 10 minus 12, square it, and then do addition, and then subtract the y coordinates, -11 minus 3. And then square the difference. That's equal to 10 minus 12 would be -2 squared, plus -11 minus 3 would be -14 squared. So -2 squared would be +4, -14 squared would be 196. That's equal to the square root of 200. So to recap what we have the distance from N to Q would be the square root of 200. So remember what we said earlier, if they're the vertices of a right triangle, then the longest side, the distance from M to Q squared, if that's the longest side, then that would have to be the hypotenuse. You'd have to take the shorter sides, distance from M to N, the distance from N to Q, square them and add them up. Remember, we said the distance from M to Q was 20, so it'd be 20 squared. The distance from M to N was square root of 200. And then the distance from N to Q was also square root of 200. 20 squared would be 400. Now when you square a square root, the squared and the square root undo each other. They just go away, so it'd just be 200. Likewise, for the second square root of 200, that would also simplify to 200. And 200 plus 200 does equal 400. So the answer would be yes, they do form a right triangle. Now here's another example of where you'd use the distance formula. It asks, are these points collinear? Meaning, if you were to plot them on the graph, would they form a straight line? Like so. Like if that's point P, if it's negative 1, 5, it'd actually be in this quadrant because x is negative over here. So like if that's point P, this is point Q, and point R is like down here, would they form a straight line? Now that's a rough sketch, so don't go off my drawing, but that's the general idea. Could you draw a straight line through all 3 points? And the way you do that is by using the distance formula. You find the distance from P to Q, find the distance from Q to R, then you see if that adds up to the total distance from P to R. Find the distance of the 2 smaller segments, see if it adds up to the distance of the whole thing. So the distance from P to Q. Since P was the point negative 1, 5 and Q was the point 2, negative 4, it'd be the square root, subtract the x coordinates. Again, it really doesn't matter which point you start with, but since we put P first, we can just start with that just to keep it simple. So subtract the x coordinates beginning with the x coordinate for P, so negative 1 minus 2. Why did I write a comma there? Should be negative 1 minus 2 squared plus, now subtract the y coordinates, 5 minus negative 4 squared. So that would be negative 1 minus 2, which would be negative 3, so that would be positive 9 after you square it. 5 minus negative 4. Those would turn to addition, so it would be 5 plus 4, which is 9, so 9 squared, which is 81. And that wouldn't be 9 squared, that would just be 9. So 9 plus 81, which would be square root of 90. Now, before we didn't square it, but since we're dealing with addition, since we're dealing with the addition here, since we're just going to be adding the distances, not doing any sort of squaring like with the Pythagorean theorem, we're going to simplify it. Remember, let's factor down 90. 90 factors down to 9 times 10. Square root of 9 is 3, so the 3 would go to the outside. So it'd be 3, and we're left with 10 underneath. So the distance from P to Q is equal to 3 square roots of 10. And we're going to go into later why that's important, why we do that. You'll see that whenever we go to actually add the distances up. Now we got to figure out the distance from Q to R. Again, since we started with Q, let's start subtracting the x's, beginning with point Q. So the x-coordinate for Q was 2, x-coordinate for R was 4, so to subtract them, let's square it, plus, now you subtract the y-coordinates, negative 4 minus negative 10, and then square it. So That would simplify to 2 minus 4, which is negative 2. Then negative 4 minus negative 10. That would simplify to 6 squared, positive 6 squared. Negative 2 squared would be 4, 6 squared would be 36. That would be square root of 40, which would be, if you want to factor it down, be 4 times 10. And remember, the square root of 4 is 2, so that would move to the outside, so it would be 2 square roots of 10. So, the distance from Q to R is equal to 2 square roots of 10. Now we have to figure out the distance from P to R. So since we have P as the first point, let's go ahead and just start with that. So negative 1 minus 4, subtracting the x coordinates and then squaring it. Now we're going to subtract the y coordinates. The y, again, beginning with point P, so it'd be 5 minus negative 10, square it. Negative 1 minus 4 would be negative 5. And then 5 minus negative 10 would be 15 squared. So negative 5 squared would be 25. 15 squared would be 225. That would be equal to square root of 250. And like in the others, so we can add them to see if they are collinear, let's factor it down. We've gotten the others to be something times the square root of 10, so let's factor it down to something times 10. 250 is equal to 25 times 10. 25 does have a perfect square root, so it'd be 5. So it would be 5 times the square root of 10, because we're left with 10 underneath. The distance from P to R is equal to 5 times the square root of 10. Alright, so now, like I said before, we need to check if the length of the two shorter sides, or the two shorter segments, equals the length of the bigger segment. So, we said the distance from P to R was equal to 5 times the square root of 10. The distance from P to Q was 3 times the square root of 10. And the distance from Q to R was equal to 2 square roots of 10. And since they all have the same square root, you just check the coefficients, the numbers in front. We know that 3 plus 2 gives you 5. So, yes, they are collinear. Now the next thing we're going to learn about is something called the midpoint formula. Pretty much if you have two segments and you want to find the point in the middle. The way you would find that point in the middle would be to find the average of the x terms and the average of the y terms. And here's a picture of it on a coordinate graph. Alright, like here in this picture, you have points P and Q, and for point M in the middle, you take the x coordinates for P and Q, x1 and x2, and you'd average them. That would give you the x coordinate in the middle. That would give you this x coordinate right here in the middle, if you average the x's. Likewise, you take the y coordinates, and you average them, and it'd give you the y coordinate in the middle. Right here, so you just take the x coordinate and y coordinate and find where they intersect on the coordinate graph, and that's your midpoint. Now, here's an example of using the midpoint formula. So for example, for this example, you want to find, for part A, you want to find the coordinates of the midpoint of the segment formed by those endpoints. So if you plot the points 8, -4, and -6, 1, and you want to find the coordinates of the midpoint. And for part B, it gives you the midpoint and one endpoint, and you have to find the other endpoint. So for part A, basically if you were to plot the point 8, -4, which I believe would be somewhere here, because x is positive here, so if that's 8, and y is negative here, so say if that's the point 8, -4. Then you have the point -6, because x is negative over here, 1, so -6, 1. If you were to connect those points, and I know my line's horrible, but hopefully you can draw better than me. What would be the coordinates of the point in the middle? Instead of trying to plot that on a graph, you can just do the midpoint formula. So average the x values, 8 plus -6 over 2. That should be a comma. Then average the y coordinates, -4 plus 1 over 2. Eight plus -6. Since you're adding a negative, that would turn to subtraction, so 8 minus 6, which is 2, and 2 over 2 gives you 1. So the x-coordinate, the midpoint, is 1. Now for the y-coordinate, -4 plus 1 is -3 over 2. That would just give you a decimal, so, we can just leave it as a fraction. So for part A, the midpoint between those two segments is the point 1 and -3/2. Now for part B, it gives you one endpoint, P. It gives you the midpoint, M. But you don't know the coordinates of the other endpoint. So what you do is you can set up the midpoint formula, -6 plus the other x-coordinate divided by 2. And then 12 plus the other y-coordinate divided by 2. That equals the midpoint of 8, -2. So if you want to split that up into two separate equations, -6 plus x over 2 equals 8. And then take the equation for the y-coordinate, which was 12 plus y over 2 equals -2. So if you want to solve the x one first, -6 plus x over 2 equals 8. Since we're dividing by 2, let's multiply both sides by 2. Those cancel out. So you have -6 plus x equals 8 times 2, which is 16. And then you add 6 to both sides. So the x-coordinate would be 22. So now let's do the y-coordinate. 12 plus y over 2 equals -2. Again, since we're dividing by 2, you multiply both sides by 2. So you end up with 12 plus y equals -2 times 2, which would be -4. And to cancel out the positive 12, you would subtract 12. So y is equal to negative 4 minus 12, which is negative 16. So the other endpoint would be positive 22 for the x, negative 16 for the y. So here's another problem pertaining to the midpoint formula. It says figure 8 below depicts how a graph might indicate the increase in the revenue generated by fast food restaurants in the United States from $69.8 billion in 1990 to $164.8 billion in 2010. Use the midpoint formula and the two given points to estimate the revenue from fast food in 2000 and compare it to the actual figure of $107.1 billion. So, the way we can estimate it, like I said, we can use the midpoint formula, create two ordered pairs, 1990. In the year 1990, the revenue was $69.8 billion. We can just do 69.8. And in 2010, the revenue was $164.8 billion. So, and since the year 2000 is right in the middle of these two, we can average the years together, 1990 plus 2010, divided by 2, 69.8 plus 164.8, divided by 2, and that would allow us to estimate the revenue in the year 2000. So in the year 2000, which is what you get when you average 1990 and 2010 together, 69.8 plus 164.8 divided by 2 would be 117.3 billion. So if you notice, our estimate of $117.3 billion is greater than the actual amount. And just so you know, in case you're actually curious, this is due to the actual revenue increasing at an annual rate of roughly $3.73 billion from 1990 to 2000. And then after that, it increased at an annual rate of $5.77 billion from 2000 to 2010. So the rate of increase jumped after the year 2000. So for each of these equations now, we're going to focus on finding ordered pair solutions, meaning x and y values that fit the equation. So for part A, for 1, the way we find ordered pairs that work is we plug a number into one of the variables and we solve for the other. So like, say when we set that x is equal to 0, we plug 0 into x and solve for y. 4 times 0 is 0, minus 1 would be negative 1. So the point 0, negative 1 is on the graph. And by the way, when x is 0, that's what we call the y-intercept. That's where it crosses the y-axis. So for another point, you can let y equal to 0. So when y equals 0, that's 0 equals 4x minus 1. Add 1 to both sides. So 1 is equal to 4x, so x is equal to, divide by 4. So x would be 1/4. So the point 1/4, 0 is also on the graph. And when the y-coordinate is 0, that's what we call the x-intercept. Now let's pick a couple other points just for funsies. Say when x is negative 2 and also when x is 1. You plug those in, so 4 times negative 2 minus 1. And then when x is 1, it'd be 4 times 1 minus 1. that would give you y is equal to 4 times 2 is -8, minus 1 should be -9, so that would be the point -2, -9, and also the point. See, that would give you 3. 4 times 1 is 4, minus 1 is 3, so that'd give you the point 1, 3. So that gives you 4 points that are on the graph. 1/4, 0, 0, -1, -2, -9, and also 1, 3. Now we're going to skip parts B and C because this video has already been long enough, and what I'm about to do in the next example applies to both of them. Applies to both B and C as well. Like the way we did this would be. Now for the last example. No, for this example, it tells you to graph the equation. Since we only did part A and part 7, we're going to do just part A and part 8. Pretty much what you do is one way you can do it is just take the points 1/4, 0, and then the point 0, -1, the point 1, 3, and the point -2, -9. And you plot them all in a graph, and then you just connect the dots. And when you do that, your graph should look like this. And if you notice, we plot the point 1, 3, 1/4, 0, 0, -1, and then -2, -9.